the threats to our nations, they don't sleep. They're watching our every move. Iran, Russia, China, North Korea, ISIS, Al-Qaeda. They may be watching this right now. We have been honed into a machine of lethal moving parts that you would be wise to avoid if you know what's good for you. We will not be intimidated. We will not back down. We've seen war. We don't want war. But if you want war with the United States of America, there's one thing I can promise you, so help me God. Someone else will raise your sons and daughters.
That video fires me up. Welcome everyone to our next generation aircraft product unveil event. Thank you so much for coming this evening. Thank you to our marketing and events team for putting this on. Thank you to our CEO, Gary Steele. We are going to keep this event short, energetic, and fun, mainly because I've lost my voice due to my 3-year-old. My name is Brandon Tsang. I'm the president and co-founder of Shield AI. I'm a mechanical engineer, a former engineering officer on board the USS Pearl Harbor, and a former US Navy SEAL. I deployed twice to Afghanistan, once to the Pacific Theater, and once to the Arabian Gulf. 10 years ago, I founded Shield AI with my brother Ryan and our third co-founder Andrew, with the aspiration to bring the best of technology, the best in AI and autonomy, to the mission of protecting service members and civilians. In pursuit of this mission, we are building and proliferating the world's best AI pilot and next-generation aircraft. And the Shield AI team, fun fact, is mission-obsessed. So before we get into the actual event and what's behind this big, big curtain, I wanted to share with you all some of the highlights achieving our mission over the past several years. On October 8th, 2023, one day after the terrorist attacks in Israel, the Israeli Yamam counterterrorism forces used our HiveMind-powered product, Nova, to help rescue hostages. This note that you see here is them exchanging a message with our team lead about how Nova helps save lives. The Ukrainians have been using HiveMind-powered VBATs over hundreds of missions. With every single one of those missions, GPS and communications is jammed to target strategic Russian assets. And what Shield AI has achieved in Ukraine, operating while GPS and communications are jammed, is a truly singular outcome that no other defense company has solved. I could not be more proud of what our team has accomplished out in Ukraine. And then more recently, the US Coast Guard and our US Navy task forces, in just the past couple of months, have been using VBAT to interdict and destroy billions of dollars worth of drugs that were headed for the United States of America. Most recently, last week, we learned that we just set a record for most drugs interdicted by US Coast Guard ship on a single deployment, 22 tons, and we're still not done with that deployment. And we've done amazing things with our AI pilot on jets. We won the DARPA Alpha dogfight in 2020, beating all other AI pilots. We were the first company in the world to fly the F-16 completely autonomously. In 2023, we did the first ever AI-piloted F-16 versus human-piloted F-16 dogfights. And all of this work is for a new generation of uncrewed fighter jets, commonly referred to as CCAs. And since then, our AI pilot has now piloted 15 different classes of aircraft. I actually can't say just aircraft anymore, because we have done unmanned ground vehicles, unmanned surface vehicles, we're doing helicopters, we're doing jets. We are doing things with AI and autonomy for the military faster, cheaper, and more successfully than any other company in the world. So what's next? Thank you. We aspire to achieve our mission at great scale. We believe the greatest victory requires no war, and to achieve the greatest victory, we must build, then equip US and allied warfighters with dominant products and technology. And so to achieve this great victory, we have been executing a simple but hard to achieve plan. Phase one of that plan is really show the value of an AI pilot working on unmanned systems without GPS, without communication, showing full mission autonomy, showing swarming. Phase two was to put that AI pilot on lots of other systems. And like I said, we've done 15 other systems to date. Phase three is about scaling to 100 million AI pilots for sea, air, land, and space applications by empowering others to build autonomy. This is what our HiveMind Enterprise SDK product is all about. It's enabling companies and governments to build autonomy for their platforms using the same developer tools, infrastructure, and pipelines that Shield AI uses. Which brings us to phase four, and what we're here this evening for, and what tonight is all about. Revolutionizing US and allied warfighting capacity by fundamentally reimagining air power. And we are going to revolutionize air combat operations by building a transformational, next-generation AI-piloted aircraft. It is truly an inspirational aircraft. If you haven't already figured it out, I promise you, you've never seen anything like it. And when you see it, I believe that you'll probably think to yourself, holy shit, that thing is fucking cool. So, no more hype from me. Without further ado, ladies and gentlemen, on behalf of Shield AI, I am proud to unveil Part 4, Phase 4 of our plan, the XBAT. I told you it's pretty fucking cool. XBAT is the world's first AI-piloted vertical takeoff, launch, and land multirole fighter jet powered by HiveMind. It's built to enable the combatant commanders with geographically distributed long-range fires and solve the problem that 5th and 6th generation capabilities are too costly. I just want to emphasize that air power without runways is truly the holy grail of deterrence. Air power that is everywhere means it creates an infinite number of dilemmas for the adversary to deal with. And so now, I'd like to introduce you all to the inventor behind XBAT and our head of our aircraft business unit, Armour Harris. Armour came to Shield AI from SpaceX, where he led Starlink satellite engineering and Starshield efforts, reporting directly to Elon Musk. Previously, he worked on Falcon 9 launch and land and the Merlin 1D engine. We like to joke that with a name like Armour, combined with his career of launching and landing things, he was destined for Shield. He was destined to bring XBAT to life. And so, ladies and gentlemen, please welcome Armour Harris.
All right, thanks, Brandon. I guess he's right about the destiny factor. Didn't occur to me that the last two things they worked on have both been called Shield, but it is what it is. All right, like Brandon mentioned, XBAT represents a revolution in air power by presenting endless flexibility for our warfighters and endless dilemmas for our adversaries. XBAT's design is really about four things. First, vertical takeoff and landing. Second, multi-role capability. Third, being purpose-built around an AI pilot. And fourth, offering 10x lower life cycle costs compared to legacy 5th-gen aircraft. In our war games, we lose more aircraft on the ground than we lose in the skies. This has been proven out in recent conflicts. You just got to go ask the Russians. In fact, Ukraine has struck Russian aircraft numerous times on the ground, taking out strategic bombers with drones that cost a few $100s. In the recent India-Pakistan conflict, India hit 11 Pakistani air bases, keeping a large percentage of Pakistan's air power on the ground, not able to do anything. Here in the United States, we've spent decades building ever more exquisite stealth aircraft that are incredibly survivable in the air, but they're all vulnerable on the ground to long-range missiles or cheap drones. So to protect our air power in theater, we have a couple of options. One, we can build hardened aircraft shelters that can protect them, but those shelters cost just as much as the aircraft. Two, we can use tankers to be able to base those aircraft farther away, but then you have this daisy chain of tankers in order to get those aircraft into the fight. Or you can build larger and more expensive aircraft that can fly farther away, but that doesn't help you with the cost problem. Expeditionary vertical takeoff and landing is the way to break that cost curve. By not being dependent on large central bases, we spread out our air power across the theater closer to the front lines, greatly complicating the targeting picture for our adversaries. XBAT is explicitly designed not just to be vertical takeoff and landing, but also road mobile, achieving rapid turnaround times between landing, moving, and launching. If you can move within your adversary's window and their ability to target you, then you can ensure survivability on the ground. Importantly, XBAT does not need a fleet of air-to-air refueling tankers because it launches from within the range of the fight. It also doesn't need dedicated batteries of air defenses or hardened aircraft shelters to protect it because it's always on the move. At sea, our nation's nuclear-powered aircraft carriers are the most valuable sovereign real estate we have. Their deck space is precious, and their air wings are deadly. Vertical takeoff and landing enables power projection from other ships in the fleet, augmenting that incredibly effective carrier air wing. So for example, on the helicopter carriers, we can carry 60 XBATs on those ships, giving them an air wing greater than many air forces around the world. We can also fly it from ships as small as littoral combat ships. XBAT can even fly from non-traditional surface combatants like cargo ships, not only presenting dilemmas to our adversaries, but also adding significantly more launch and land options. With XBAT's range, the ship it's flying from can stay out of harm's way, so it doesn't need a ton of expensive defensive systems. Let's talk a little bit about XBAT's design. So XBAT has a simple propulsion system. It's an F-16 class engine straight down the middle with an afterburner and a thrust vectoring nozzle originally developed for a late 1990s F-15 thrust vectoring program. This solves a lot of the problems that VTOL designs have historically had. So if we compare it to something like the F-35B that has the complex lift fan system that takes away fuel volume, takes away payload capacity, makes that variant of the aircraft less mission capable than the conventional takeoff and landing variants. But we solve that problem by not needing that complex secondary propulsion system. So we made up that simple propulsion system with a tailless design that has fundamentally good high lift-to-drag ratio, meaning, in the words of one of our Top Gun aviators, this thing hauls ass and sips gas. Because it's got a big engine and a relatively small aircraft that gives it a pretty high cruise altitude, and it cruises extremely fast, so it's one of the highest flying and fastest things in the sky. The design is also inherently stealthy, giving it the signature it needs to survive in modern air combat. We've talked about XBAT, but we should also talk about the launch and recovery vehicle, which is a critical component of the system. So the launch and recovery vehicle solves survivability on the ground because it gives it the road mobility, and also consolidates all the ground support equipment usually required for an aircraft the size of XBAT into an expeditionary package, truly enabling agile combat employment. So the way the system works is, first, the launch and recovery vehicle positions XBAT for launch. There's outriggers that deploy to give it stability. The aircraft is raised vertical with hydraulics. The engine throttles up to max afterburner. The aircraft is launched off the launch and recovery vehicle just like a rocket taking off from a launch pad. XBAT really is, in many ways, the marriage of a rocket and an airplane. We actually take another page out of the rocket playbook by incorporating a blast deflector, which protects the ground or the ship deck from the exhaust of the engine during both launch and recovery. So once the aircraft is up, performing its mission, powered by the autonomy, and it's ready to come back in for landing, it transitions from horizontal flight to vertical flight with what's called a Cobra maneuver, rapidly dumping that horizontal velocity, transitioning to vertical flight, and then it comes down for a landing on the launch and recovery vehicle, very similar to how a bird lands on a tree branch. When it comes down to land on that launch and recovery vehicle, it then gently powers up into a latching mechanism. And this actually gives it a go-around capability that other VTOL aircraft don't have. This might sound very novel, but actually XBAT is not doing anything that hasn't been proven before. And a key tenet of the XBAT design philosophy is to integrate mature technologies into an elegant and compelling package. So this aircraft, called the X-13, demonstrated vertical takeoff and landing from an articulating trailer dozens of times, actually including on the lawn of the Pentagon out here, but it had two drawbacks. One, it had early 1950s era jet engine technology, so low thrust, poor fuel consumption, just couldn't carry a useful payload for a useful range, so it wasn't that useful as a tactical aircraft. And second, it was piloted by a human. And every human pilot in this room will tell you that that's a pretty hard maneuver to pull off, despite the fact they were able to do it several dozen times. This is solved by the modern guidance, navigation, and control algorithms that we've developed as part of the HiveMind software stack that enables the aircraft to land on the launch and recovery vehicle autonomously without the need for a human pilot. Talking about XBAT's offensive capabilities, XBAT has the size, weight, and power needed to carry the sensors to be able to be standalone, unlike any other autonomous aircraft on the market today. And actually, in many senses, XBAT is really the world's first autonomous fighter jet because it has the ability to organically close its own kill chains without reliance on third-party assets. In order to do this, it has a wide variety of sensors, both active and passive, leveraging the electrical generation power of the large engine that's installed. And it also has internal weapons bays and external hardpoints, giving it the ability to carry the full arsenal of air-to-air, surface strike, air-to-ground weapons. And then you can also install electronic warfare payloads, allowing you to conduct jamming missions. You can put all the watts that that engine generates downrange, greatly complicating our adversary's targeting picture. Shield AI is the world leader in AI pilots for military aviation, and that AI keeps getting better every few months. XBAT can operate collaboratively with other manned assets, but as the capability, as the autonomy grow, it actually doesn't need to. So XBAT's autonomy presents many options to the mission planner depending upon the rules of engagement. So in this example behind me, XBAT's engaging in a counter-air mission. XBAT can be assigned a box of airspace to control, say, in front of a carrier battle group, and if it detects anything inside of that airspace that doesn't pass the friend or foe checks, it'll automatically engage it according to what the rules of engagement are. Importantly, XBAT's autonomy enables it to continue the mission even if the comms link is severed. And the autonomy architecture also allows the aircraft to work together collaboratively in a pack. Perhaps one aircraft is acting as a sensor, the other aircraft are staying passive as the shooters. At Shield AI, we've been working hard on XBAT for about 18 months now. We've completed a wide variety of wind tunnel testing, validating that the aircraft is able to do that transition from horizontal to vertical and back again. We're ensuring we can feed the inlet with clean air during that whole maneuver. We've also conducted pole testing, verifying that the radar cross-section of the aircraft is what it needs to be in order to meet the mission requirements. We're building a structural pathfinder that gets pushed and pulled on to verify that the airframe can meet the G-force requirements it's going to need to survive in flight. We've also been conducting engine testing, demonstrating that the engine has the throttle bandwidth needed for that landing maneuver, also integrating a thrust vectoring nozzle on the test stand. We're actually moving towards first vertical takeoff and landing flights in 2026, about 12 months from now, and then full mission capability flights in 2028. Our aim is to bring this capability to the Joint Force as rapidly as possible. But at Shield AI, our real product is not just the incredible aircraft we build. Our real product is the team, and we're proud to have built the best team in aviation. I truly believe that the team that we've assembled is the best of the best, and that's what's enabling us to build something as disruptive as XBAT. We're driven by and inspired by our servicemen and women who are putting their lives on the line every day. We have many former servicemen and women on our team. They're an inspiration to us, and we really see our role as giving them the greatest advantage possible so that they can safely come home to their families after every deployment. We believe that the greatest victory requires no war because our adversaries realize that we have a decisive advantage. The fundamental goal of XBAT is to present an asymmetric dilemma to our adversaries. This aircraft is capable of taking on the toughest mission assignments, going up against targets that have a value many times greater than what this platform costs. And that asymmetric advantage enables us to maintain the deterrence lead that the United States currently has. And our goal is that our adversaries wake up every day thinking, today is not the day that I should start a war. Today is not the day that I should invade my neighbor. This is really the mission of XBAT and the mission of Shield AI. We're proud to announce XBAT to you. Thank you all so much for coming. We're honored to have so much support. Please enjoy the evening. You can come up and take pictures with the XBAT. You can hang around and mingle, and we hope you all have a great evening. Thank you very much.